Think about the screen you're looking at right now. The deep reds, the vivid greens, and that crisp high-definition glow. Now, think about the lasers used in life-saving eye surgeries or the powerful magnets inside electric vehicle motors. What if I told you there is one single, secret ingredient, hiding in the periodic table that makes all of this possible? Enter element number 39, yttrium. It's not as famous as gold or oxygen, but without it, our modern digital lives would literally go dark. From the depths of a tiny Swedish mine to the forefront of cancer research, yttrium is the silent titan of technology. Today, we're breaking down the mystery of this rare earth element and why it's the most important metal you've probably never heard of. Let's dive in. The origin story. A village called Yttrium. Our story doesn't start in a high-tech lab, but in a quiet quarry in Sweden back in 1787. An army officer and amateur geologist named Carl Axel Arrhenius stumbled upon a heavy black rock that looked like nothing he'd seen before. The discovery? He sent the sample to Professor Johann Gadaland. In 1794, Gadaland managed to isolate a new earth, or oxide from this rock, which he named yttria. The yttrium legacy. Here's a mind-blowing fact. The village of Yttrium is the only place on Earth to have 4 elements named after it: yttrium, terbium, erbium, and ytterbium. The pure form. While the oxide was found early on, it wasn't until 1828 that Friedrich Wöhler finally isolated pure yttrium metal. It took us nearly 40 years just to see it in its true form. Physical and chemical profile. The rare identity. So, what exactly is yttrium? The look. In its pure state, yttrium is a silvery metallic transition metal. It's relatively soft and shares a lot of chemical DNA with the lanthanides. The rare earth myth. You'll often hear it called a rare earth element, but here is the kicker. It's not actually that rare. It is more abundant in the Earth's crust than silver or tin. The rare part comes from the fact that it's incredibly difficult to find in a pure, concentrated form. The fire factor. Yttrium is quite stable in bulk, but if you turn it into a fine powder, it becomes pyrophoric, meaning it can spontaneously ignite in air at room temperature. Talk about a hot element. Revolutionizing the screen. The red color miracle. This is where yttrium changed the world forever. If you're a fan of cinema or gaming, you owe a huge debt to element 39. The color gap. Back in the early days of color TV, scientists struggled to produce a bright, stable red color. Everything looked dull and orange. The yttrium solution. In the 1960s, engineers discovered that using yttrium vanadate doped with europium created a brilliant, glowing red. The tech evolution. This discovery didn't just give us better TV, it paved the way for the LED and phosphors used in your smartphone screens today. Every time you see a vibrant red sunset on your phone, you're looking at the power of yttrium. Medical miracles. Fighting cancer beyond gadgets, yttrium is a literal lifesaver. In the world of nuclear medicine, its isotope yttrium-90 is a superstar. Targeted warfare. Doctors use yttrium-90 in a procedure called radioembolization to treat liver cancer. They inject tiny glass beads containing yttrium-90 directly into the blood vessels feeding a tumor. The precision strike. The radiation travels only a tiny distance, about 2.5 millimeters. This means it kills the cancer cells with surgical precision while leaving the surrounding healthy tissue mostly untouched. Pain management. It's also used to treat severe inflammation in joints, helping people with chronic arthritis regain their mobility. It's not just a metal, it's a tool of healing. Superconductors and the future of energy. If we want to reach a future of limitless clean energy and levitating trains, yttrium is the key. YbCO, the game changer. In 1987, researchers created YbCO, yttrium barium copper oxide. This was the first material found to be a high-temperature superconductor. Why does this matter? Most superconductors only work at near absolute zero temperatures. YbCO works at the temperature of liquid nitrogen, which is much cheaper and easier to manage. The result? This material is used to create incredibly powerful magnets for MRI machines, particle accelerators like the Large Hadron Collider, and potentially, fusion reactors that could power the entire planet. Industrial muscle. Lasers and alloys. We can't forget its tough side. YAG lasers. Ever heard of a YAG laser? The Y stands for yttrium. These lasers are used for everything from cutting through thick steel plates in factories to performing delicate dental surgeries and removing tattoos. Jet engines. Yttrium is added to alloys used in jet engine turbines. It makes the metal resistant to the extreme heat and corrosion found inside a roaring engine, ensuring planes can fly longer and safer. The unsung hero. From a dark rock in a Swedish village to the very heart of our smartphones and hospitals, yttrium has proven that you don't need to be famous to be essential. It is the bridge between basic chemistry and the high-tech future we are building every day. What do you think? Is yttrium the most underrated element in the periodic table? Or do you have another favorite, hidden hero? Let us know in the comments below. If you enjoyed this deep dive, don't forget to smash that like button and subscribe for more journeys into the building blocks of our universe. Until next time, stay curious.